Okay, now let's look at what's called one-sided limits. So when I approach x equals 2, I can do so from two different directions. I can come from the left or I can come from the right. On the function itself, these arrows look like this and like this. Let's change colors for the other guy. So when x approaches 2, I can do so in two ways. Now, this red guy is what I'm talking about here. Okay, you'll notice it looks like a normal limit, but we have this little plus here, okay, indicating that we're approaching 2 through x values that are bigger than 2. And over here, with the second limit, and the little minus here, the minus is indicating that we're approaching 2 through values that are smaller than 2. Okay, but the idea of a limit stays the same. Okay, we're asking in this limit here, okay, what does x squared approach as x goes to 2, but goes to 2 in a specific way? It's this green arrow. Okay, on the function, we're talking about this green arrow here. Okay, so I think you'll agree in both cases, as the x values approach 2, the y values approach 4. So we get a 4 here, and we also get a 4 here. If I want to do this algebraically, okay, you can just plug things in such a simple situation. Okay, there's nothing strange happening here. Okay, we'll see eventually where strange things can happen, but here we have just a simple polynomial. You can just go ahead and plug it in, and you get a 4. Okay, so even without this picture, you can calculate these things. And likewise, the other one can be done algebraically as well. Just plug that guy in, and you get 4. Okay, so a very simple situation. Let's look at something a bit more strange. So we'll pan over here, and what do we get? Okay, a bizarre kind of broken function. Okay, it's a function broken into two pieces, 2 pieces, but same function. And we're going to look at the two limits. So how about limit x goes to 2 plus of f of x. Okay, we'll use red again for this one. Now when you're doing 2 plus, you're looking at what this arrow is approaching. And I can see that that's approaching the y value 3. Now if I want to look at the other limit as x goes to 2 minus of f of x. Okay, again, the minus indicates that we're approaching 2 through values that are smaller than 2. So we're approaching this way. So what's happening there? Well, I'm going to get 1 here. Okay, so these are not the same. So the one-sided limits are different. Now what do you think? Let's look at what's called the overall limit here. Limit x goes to 2 of f of x. Okay, we're not indicating a side that we're approaching to from. What do you think this is? Well, when I approach from the right, I get 3. When I approach from the left, I get 1. So does it make any sense to assign a value here? No, it does not. It makes no sense to assign a value here. Okay, it's not 1, it's not 3. We just say that this does not exist. Okay, we have no reason to choose 1, we have no reason to choose 3. Okay, there is no single value that f is approaching as x goes to 2. Okay, we'll summarize this in a little statement down here. Okay, you should copy this into your notes. It basically says what I just outlined in the example there. Okay, if you want the overall limit to exist, or to equal a number, L. Okay, when I say exist, what I mean is equal a real number. So if you want that to exist, you need the one-sided limits to agree. And they have to actually equal that L value. Okay, one detail here. If, this is not a typo, if is a math short form for if and only if.